Hey everyone, it's Miss Scoop and today's lesson is Unit 2, Lesson 2. We're talking about the area of right triangles. So this might be brand new. For many, many years, you've probably been working on the area of rectangles, but you might never have worked on the area of triangles. So this might be brand new for you. So let's start by refreshing ourselves on what right triangles are. So here's what they are. We have to wait for a minute to load. It always takes a minute, There we go. Right triangles. So right triangles are triangles that have one 90-degree angle. But could they have more? Try to draw a triangle that has two 90-degree angles. Try to draw a triangle that has three 90-degree angles. Pause the video and draw that on your paper. Try to draw a triangle with two right angles and a triangle with three, and then start the video again. So pause now and do that. All right, if you tried it, it probably looks like something like me trying it too. Here's the one that makes sense. There's the 90-degree angle right there, but the other two have to be smaller to connect. If I make two 90-degree angles, I kind of make a U shape, like a squared out U shape. If I try to make three 90-degree angles, I end up trying to make a rectangle. If I don't connect them, it's not a triangle anyway. And plus, it didn't have three sides anymore. So you can't make a triangle that has more than one right angle. So right angles have one 90-degree angle. Now, you can also name, and so anytime you see a 90-degree angle like this, let's see if I can use my special pointer here, like this, right there. See how that has that little square corner? Means it makes the corner of a square. That means it's 90 degrees. Or here, that's 90 degrees. So, but you can also name right angles something with two names. So let's take a look and see what the two name choices are. You could have an isosceles right, where two sides are the same. You could have a scalene right, where no sides are the same. But could you have an equilateral right? What do you think about that? All right, let's go on to the next page. Let's see if it just lets me do that. There it is. Now, we are going to learn about making the area of right triangles, finding the area of right triangles. Here's what you need. You need 4 sheets of paper and a scissor. Now, typing paper, computer paper works best. If you have some old ones like I do that are like mistakes off a printer or something like that that's going to be recycled anyway, paper that you've used already for whatever reason and you don't need it, that's even better because then we're just reduce, reuse, recycling. If you don't have computer paper, notebook paper works, but you have to take off the fringes. So pull out a sheet of notebook paper, and if you have those fringes on it, cut really carefully up there. You also need a scissors. You can do this with folding and pinching and going back and forth and ripping, but it's really, really hard. So find a scissor. Take a minute. Go ask your family if you need to where you have a scissor in your house. So find a scissor, and you also need paper. Pause the video, go get that, and come right back. All right, welcome back. We're going to start with one of your sheets of paper. So grab one of your sheets of paper. Now, this is probably really familiar for you. The first part of this lesson, super easy. The second part, I'm not going to lie, it's hard, and it's really hard for some kids. So don't give up. Rewind the video if you're not sure what I did and try again. Have someone else watch it with you and help you if you just can't figure it out. So you can do it. I've had every 5th grader, every 6th grader that I've ever taught been able to do it, but some it's just really hard for. So take your piece of paper. This is not the hard part. Take your piece of paper, fold it the hamburger way. I probably don't even need to show you how to do that, right? So here's your paper, and there it is. And when we fold it so that it makes the fatter fold like that, we call that the hamburger way. Open it up. There it is. Fold it the hamburger way. Cut that apart. Pause the video. Do this. Cut it apart. And then come back when you're done with what you see me doing right now. Okay? All right. You're back. I'm back. The question is, how much of the rectangle is each one of these sides? We put it together. We took it apart. We put it together. We took it apart. How much is each one? I hope you said half. Each one is half because we just cut it in half. We folded it in half. We cut it in half. It's half. Easy peasy. I hope that was the easy part of the lesson. This next part is the second easy part of the lesson. Grab another sheet of paper. Here it is. Now, this time we're going to fold it the hot dog way. As you remember, the hot dog way means that you're going to make it look long and skinny when you fold it, and it's going to look like a hot dog bun. So, fold it long and skinny, open it up. There it is. And again, you're going to cut it right on the fold that you just made. Fold it, open it up. Oops. Oh, my cutting wasn't very straight on that one, but you can try to do better than I did on that one. Got a little rough. There it is. Fold it, open it up, cut it. Pause the video and do that. All right, we're back. Here it is. Apart, together, apart, together. How much is each of these? I hope you know this. It's half. I hope you were thinking, yeah, it's half. That's an easy one. So even though it looks different, it's still half. So take one of the hot dog way and one of the hamburger way. Notice those look quite different, but they're still half of the sheet of paper. So if we put these together somehow, it would actually make a whole sheet of paper. It would look weird, but the area would be the same because when we take those apart, it's half. When we take these apart, it's half. Buckle up. This is the hard part. All right. You need another sheet of paper. And I'm not going to lie, this is the hard one. Here we go. What you're going to do is fold this one so that the opposite corners, I'm going to back up a little bit so you can see this better. The opposite corners where your fingers are, hold one on top and one on bottom, like I'm doing. Those opposite corners are going to turn into little points because you're going to fold a line so that this corner and this corner fold in half. Now watch this. So I'm going to keep my fingers here because those points need to turn into points. I'm going to lay the paper flat like this. And now look what I do. I'm going to put one finger under my two fingers, my thumb and my finger underneath the paper, and I'm going to fold it up towards each other. Now this is tricky. The points that are folding are not going to come together. They won't match up. It's going to look like two mountains. But look what I'm doing over down here with my down there. I'm making it into a point. So I'm going to roll it even a little bit more so that it turns into exactly a point. I'm going to do that on the other side too. Whoops, there it is. I'm going to turn that into exactly a point. Whoops. There we go. Now, notice how I haven't creased it yet, but it's starting to look like two mountains. I'm going to put it down and crease it. It's a lot easier to set it down, but I'm going to be it on the camera, so I'm not going to set it down. But look at this. I'm just going to fold it and crease it so those points along the bottom, those stay as points. Notice they're points. Notice they're points. And then the line goes straight across like that. I'm going to fold it like that. Notice that the top looks like a mountain, and you can see the back side of one of the papers and the front side of the other. Now, if yours is an old recycled paper like mine, it's easy to see. If yours is just plain white, it's a little harder to tell that. This is what you're trying to get. So let me show it to you again. Open. See how the fold goes straight from the top left to the bottom right? That's what you're trying to do. You're trying to fold it in we call that diagonal. Uh-oh, my computer's doing something messed up again. All right, sorry about that. I'm back. So yours, when you open it back up, you should see that diagonal fold. from the top of one corner to the bottom of the other. That's what we're doing. We're folding it in a diagonal. So put your two fingers where you want the folds to be, fold it, and make it look like mountains. You can watch this as many times as you need to, but it needs to look like this when you're done. So pause it and do that. Don't do any cutting until you come back. Pause it and do this. Ask for help if you need it, because this does trick kids. But you can do it. Rewind and watch that part. Watch carefully and try it again. You might need a couple sheets of paper to try it. If one gets all garbaged up while you're working on it, put that one to the side and take a new one. All right, we're back. If you're on this part of the video, it's because you've gotten this diagonal fold going. It's because you're ready to do the cutting. You're going to do just what we did with the hot dog and hamburger. You're going to cut right along that diagonal fold. So go ahead and pause the video and do that now. There it is. Now, you have cut it into these two shapes. Now you might say, wait a minute, they don't match. But the actual is they actually do match. You might have to flip one over. You might want to have to rotate it. You might have to work with it a little bit. That's not it. But they actually match up perfectly. Look at that. Now's the question. How much of the whole thing is each of these? I hope you say it's half. Look at that. Now, this half of the rectangle looks different again, doesn't it? It looks different than from the hamburger side. It looks different from the hot dog piece. But you just cut that rectangle exactly in half. And if you flip it over and match it, it matches up. So both pieces are exactly the same size and they match up. So when you cut a rectangle in half, you get a triangle. Or rather, you get two triangles. And each one is a half. Surprise! That's a new thing for a lot of kids. A lot of kids are like, dude, I didn't know that. Look at that. So a right triangle is half of a rectangle. In the same way that the two halves of a hamburger way are half a rectangle, the two halves of hot dog way are half of a rectangle. These two halves, when you rotate them around, you can see they match up. Each one is a half a rectangle. That's going to be super important to understand today's lesson. So pause and play with that a little bit so you understand and see how that can work, how a right triangle is half of a rectangle. All right, we're ready to go into our book. So let's take a look. We're in Unit 2, Lesson 2, and this is on page 61. So please grab your book and open it up to page 61. Page 61, we're going to do number 1. We're not going to do number 2 and 3 today, so I'm going to put an X over those today. We may come back to those, but don't do them today. Okay, so join back with me on, whoops, I'm going the wrong way here with my mouse. Or my computer's just slow, I guess. There we go. Join with me on number 1. It says, look at figure A. Figure is just another name for a picture. And it says it's picture A. So look at shape figure A. There it is. What is the area of the rectangle? So we know how to find the area of a rectangle. We know it goes, there's 1, 2, 3, 4, 5, 6 centimeters across, 1, 2, 3 centimeters up and down. We could count the squares. We could count 1, 2, 3, 4, 5, 6, and we could keep counting. We could count all those squares to figure out what the area of that green rectangle is. But we don't need to, because we know the area of a rectangle, the formula is base, the part it's sitting on, times height, how tall it is. We know it's base times height. So this is 6 times 3. 6 times 3, we know that's 18. And then we can't leave off the markings of how the size of the units. It's not 18 miles, it's not 18 meters, it's 18 feet, it's 18 centimeters. So we have to put on the label centimeters. CM is the short version for centimeters. And then remember, it's how many squares are covered. It's not just a straight distance line. That would be centimeters, just how far in straight distance. But this is how many squares, how many 1 centimeter squares does it take to cover this whole area? Well, so it's square centimeters. So we have to put that little 2 up above. So 18 square centimeters. Now it says draw a diagonal line and make 2 triangles. That's what you just did when you were folding your paper. So I'm going to go and grab my eraser tool here a second and erase this stuff that I wrote here, if I can. There it is. All right. So I clear my space up a little bit. I'm having a hard time erasing. Oh, my computer's just slow, I guess. There we go. Well, we'll call that good. Oh, there we go. We'll call that good. Okay. So I'm going to go back to my drawing tool. And I'm going to get a different color. All right. Now, we need to draw the diagonal. You folded the diagonal. It went from the top of one corner to the bottom of the other corner. You did that when you made this. When you made this, that was a diagonal. So you're going to draw the same thing here. Draw a diagonal. So it's a line that starts in one corner and goes straight down to the bottom of the other corner. There's my diagonal. So I drew a diagonal line. And look, I made 2 triangles. There they are. There's one. And there's the other one. What is the area of each triangle? Again, we're talking about how many little squares does it take to cover the surface of that triangle. The tricky thing is we notice that some of the little surfaces are only a little part. They're not the whole thing. So unlike in a rectangle where we can just count all the boxes if we want to, all the little squares, with a triangle, that doesn't work very well because some of them are teeny tiny or just a little sliver of a triangle, just a little part of a box. So it makes it really hard to see what we should count. As a matter of fact, I'm going to go ahead and try to erase here a little bit better and draw one line so we can easily see that. Here we go. I'll only try a different color here. I'm going to try white. That might be easy to see. So take a look at this. You should be drawing this line on your paper too. Look how hard it is. We don't know how much of a little chunk that is, or a little chunk that is, or a little chunk that is. We've got to use a different system. What's our system? It's what we just practiced. The fact that when you take a rectangle and you cut it on the diagonal, one of the triangles is half of the whole thing. So when it says, what is the area of each triangle, that talking about what's the area of this one triangle? And the answer is it's half of the rectangle. So if the rectangle was 18, one triangle, I'm going to draw a picture there, equals 9 square centimeters. And I know it's 9 because here's how we figured it out. We did the area of, sorry, this writing is really rotten, area of a right triangle equals 1/2 a group of base times height. So we did, let me grab the text box tool so I can write that a lot easier. Here we go. Area of a right triangle equals 1/2 of the base times the height. Oh, there we go. Change the color of that if I can, so it doesn't blend in with their writing. Is that going to work? There we go. So that's so important for today's work, that when you know the area of the rectangle, you cut it in half, and that's one of the triangles that makes. It's also the other triangle that makes. So those two triangles, when you put them back together, they make the area of the rectangle. Let's go on and try one down below. Now we're going to page 62. There it is. A triangle with right angles, those are square corners, is called a right triangle. Yep, we remember that. The area of any right triangle is half the area of the rectangle with the same base and the same height, or it's the same area as a rectangle with half the base and height. So take a look at what they're doing here on number 4. They are, I'm going to find my cursor. There it is. I want to be on the drawing tool. There it is. They say, here's the triangle we're trying to find the area of. In order to do that, we're going to just make that triangle into a rectangle. What that means is they're taking our half of paper, like this, our half a triangle, and they're just sticking back on the other half that we cut off. So they're doing it backwards compared to what we did. They start with the half of the triangle. They draw on the other half so they can find the area of the rectangle, and then they cut it back in half. So look at this. That's what these dotted lines mean. So look, there it is. So they say this is the rectangle that when we cut it on a diagonal, we cut it off, and that makes the triangle. So if we were finding the area of this whole thing, it would be base 4 times height 5. It would be 4 times 5. That's the area of the whole rectangle, the whole thing. Well, 4 times 5 is 20, so we know the whole thing is 20. If the whole entire thing is 20, we only want half. We only want what would happen with the diagonal when we cut it and take away the half, just like we did with our papers. So we're going to draw that diagonal back in. There it is. And we only want to talk about half. What's half of 20? It's 10. Now, we can't just leave it as 10. 10 what? 10 dogs? 10 chickens? 10 miles? Nope. The label was centimeters. And remember, it's not just a distance. It's how much flat surface area. So it's actually square centimeters. It needs a 2 on it. All right. Let's go on to the next 2. Don't let these lines that they drew here confuse you. This actually confuses kids sometimes. So let's draw different lines. So here's right here, number 5 and 6. There's our rectangle, just like we drew with our paper, just like we made with our paper. We're going to put the other side back on. So we're going to make it like this into a rectangle. Now we know our rectangle base, 8 times height, 3. 8 times 3 is 24, but we only want half of it. So we're going to do 1/2 of a group. And remember, of a group means multiplication. 1/2 of a group of the base times the height. And that is what gives us the area of a triangle, the area of a right triangle. Remember, 1/2 of a base times height. Also on number 6, let's do the same thing. Let's redraw those. Don't worry about the line they drew. Let's just draw this into the whole rectangle, doing the opposite of our paper folding. There it is. Now, we know base times height is the area of the rectangle, but we only want half. Good luck. If you have questions, see me in office hours. And remember that the answers to this are in your Math Google Classroom. They're listed under Student Activity Book. They're listed under Unit 2. So go and check your answers to see how you're doing. See you next time.